Hey, g'day, it's Prezzo. Thanks for stopping by. Now this is episode 8 of building Threadexpress version 3. Now if you're not familiar with the project, there is a playlist and the link is up there now. And if you know nothing about it, go back and look at episode 1 and it will explain the scope of Threadexpress, what it can do and how I got involved in the project. Now in today's video I want to make this one single assembly. This is a 3D printed and wooden mock-up that I made a while ago to check the mechanism to make sure it would actually work. And this bottom section of this mock-up is called the ratio arm, and this bracket is called the pivot support arm. Now they look like simple components, but there's a bit involved in it and they do need to be accurate. And you might be saying, well gee, that's not much to get done in one single half-hour video. But there are reasons for that. The thing you need to understand about being a YouTube presenter is that it's not all beer and skittles. It's all about managing schedules and dealing with conflicts that pop up from time to time and unexpected events. And that's certainly what's happened in the last 2 weeks, and I'll explain that toward the end of the video. And these two components here are sort of like the secret components that make Threadexpress work. And early on, Cliff Hall, who's the inventor of Threadexpress, wasn't releasing any details about these sorts of components, but he's since gone ahead and actually released his own videos and is now happy to share the mechanism. And the drawings, which I've got in here now, are going to be released soon. And again, you need to be patient and wait till I finished all of these components. Now the other thing I've been able to do in today's video is to fit this assembly to the Bridgeport mill. Now up until now I couldn't actually be sure that it would fit and that we'd be able to make it work with the Bridgeport mill. The thing is that there's only two of these things in existence. There's this one and the one that belongs to Cliff Hall, the toolmaker in New Zealand. And he has a knee type milling machine, but it's not a Bridgeport. So we need to be sure it would actually fit and function on the Bridgeport, and I can verify that that is actually going to happen. So we're going to head over to the mill and we're going to make some parts, and then I'll show you how I got this mounted on the Bridgeport. So let's get to it. Machining this pivot support arm to the correct thickness of 25mm is a bit of a challenge. The 123 block that I'm using to grip this with is more than 25mm in height. So I've had to drop that down lower, and that means pulling this parallel out so I can clear the 123 block. But I think it's going to be okay. I'll just take very light cuts, and then I need to do some machining on the inside surface to make sure everything is square. And it looks like a really straightforward part, but it's a real nuisance to grip it. Okay, that seemed to go okay. I'll get a measurement on that and then I'll just finish off this surface to 25mm in thickness. Okay, what's that? 27.33. 2.33 to come off. Alright, I'll deburr that and then we'll look at the next operation. Now that I got that to the correct width, I want to clean up these two outside faces and just get them flat and square to each other. And then the whole piece of angle has to finish at 7mm thick. So once I've done the outside, flip it over to the inside Then I'll cut the legs to the correct length. Just change the setup to do this shorter leg of the angle. So I got the previously machined face up against the back jaw of the vise. Got one of these little screwy screwball things in the front here, because the inside face at angle is not likely to be accurate. 1, 2, 3 block on this side to ensure that it's standing up vertical, and I've got a little tiny machinist jack underneath the surface here. And I'm going to use a small end mill to machine this so I don't get too much chatter. Just realised before I break this down I might as well machine this end face here. Just do very light cuts and bring that back to the correct length. Nope, I'll do it another way. I've set the Z depth so this part finishes at 7mm thick, so I can just flip it over and do this shorter leg, and then we've got to get to work and cut a slot in this longer leg. Not sure if I'm going to get any closer to that internal corner there. I might need to finish that with the file. I've marked this slot just with some layout lines, and this is where a bronze pivot block is going to slide up and down. So I'm going to finish it out with a 6mm carbide end mill in the corners and just knock out most of the stock first, and I'll go around the perimeter. I wasn't really looking at the layout lines when I did that. I was watching the DRO, so I had my 4 corner points set up and I just tracked between the 4 corners. Well, there's our almost finished pivot support arm done. It needs to have a pair of clearance holes drilled in the bottom here, and it will eventually bolt onto the end of the lever. I also need to put a similar slot to what we've got here in the end of the lever. And while I have this set up in Touch DRO, I'll go ahead and do that off camera. But I've been thinking about how I'm going to get this pair of holes drilled in the end of the lever, and they have to be tapped as well. Now, I'm not sure if it's viable to stand this upright in the vise and try and do it vertically. I think it's just going to flop around all over the place. So what I've decided to do is put it in the vise, and I'm going to use a 90-degree head on the Bridgeport to drill in from the end. While I've got the 90-degree head set up, I'm going to drill and tap the pair of holes in the back of the milling machine table so we can bolt Threadexpress onto the table. So I'll get all of that set up and we'll do that. And then we can probably put what I've got already bolted on the back of the table and just see how it's all going to fit. Now I've got the right angled head set up on the Bridgeport here, and when you set these up you need to run the indicator along this machined face here to ensure that it's aligned correctly, in this case with the x-axis. So we just sweep that edge. If that's looking good, you lock the 2 screws around the side of the head here, and I got my little probe set up so we can find the center of the stock in the vise. Okay, we'll probe this closest edge and do the back one, set the center in Y. Okay, set the origin at the center. Now we'll probe the bottom edge underneath, and I've got to come up 6 millimeters from that lowest point. Okay, just ran into a problem. I realized that Touch DRO, or at least I don't know how to do it, I don't know how you probe in Z. Looking at the screen, you can probe an X and a Y edge. But I can't see anywhere to probe in Z, so I may have to use a conventional indicator. Yeah, didn't think that through, did you? You idiot. Okay, so we found our bottom edge in Z. I've just got to offset 2 millimeters, which is the smaller diameter on the probe or the edge finder, and come up another 6. Okay, so that's our 8 millimeters there, and we've got to come 8.5 millimeters either side of center and drill 4 M5 screws. I've set up with my small chuck here and a spot drill, and fun fact, these right angle drives will reverse your spindle direction, so don't forget to compensate by switching your motor over to reverse, otherwise, yeah, you know, have a bad day with your drill bit. I'll run a bottom tap into those holes on the bench, but now that I've got the right angle attachment set up, I need to swivel this around to 90 degrees so the chuck is facing towards the operator, and we'll set up the drill holes in the back of the XY table. I went ahead and I milled the slot in the end of the ratio arm too, so it just needs to be chamfered, but that part pretty much is done now. Alright, brief overview of what I've had to do to get this to work. So I've retracted the ram almost as far as it will go, and I swiveled the ram round to about 45 degrees. And if we come around this side, you'll see the right angle attachment, and I put an indicator on the side and I swept the indicator along this surface here, and I've got it square. And there's my drill chuck, and I've got sort of just enough room for a spot drill and maybe like a stubby drill, so we can get a tapping size hole started. And I've got the drill chuck in position for, roughly in position for one of the holes. So you're probably thinking, just, you know, use a cordless drill and set it up by eye, but I think we can do better than that. I really want to make sure the hole centers are accurate, and I can use the DRO to do that. And I want to get them started square. So I'll get set up with a little spot drill and we'll give this a go. I've used this regular edge finder here to locate the very center of this coolant drain. Now that's going to be my reference for when I drill a pair of holes either side of that coolant drain there. And this is a spacer plate that I made up off camera. Now I need this in order to allow Threadexpress to clear this glass scale cover on the back of the table. I didn't realize it when I first started designing Threadexpress, but it was a simple fix, and it's going to bolt in between this casting, which is the main mounting for Threadexpress, and the back of the table. So I'll go ahead now. I've got to offset 45mm either side of center, and we'll drill and tap. I only drilled 10mm deep there in the side of that table there. I'm just a bit wary about drilling into the dovetail or any details. Yeah, probably had stacks of room, but 10's enough. Well, there's the finished ratio arm assembly, and you can see here I drilled a pair of holes in the back of this pivot support arm, and that's just fitted together with a couple of M6 socket head cap screws. Now this is the 3D printed mock-up that I made some time ago, and you can see that they're almost identical. The only difference is that this one has a radius end, but it doesn't need that. It works fine just with a square end and two chamfers. So there are a lot more parts still to be done with both these assemblies. So there's that, and also about a 4-part assembly that fits on the other side of the ratio arm like that. Now I was hoping to get that done. As it turns out, just other things have gotten in the way. I'll talk you through that shortly. But what I want to do now is put this into Threadexpress and mount it on the Bridgeport table, and I'll just show you how that's going to look when we're actually using it for cutting threads. So just hang tight, I'll get this assembled and we'll have a look. Alright, I was just doing this assembly and I thought you needed to see this. Now this backs up why I don't want to release the drawings for Threadexpress just yet. So what I've done here is I've put the ratio arm in place. It pivots on this little pin at the back here on this block, and I've used the 3D printed nut and the nut carrier and the little bronze blocks that slide in the slot there. and I wanted to just check that everything was working okay. And then I looked inside and I realized that there's not enough clearance where this bracket ends. So you don't have to go too far before that starts to clash with this side plate here. Now, I don't know what happened. When I made the mock-up of this, I didn't have this side plate in place here, just so I could see what I was doing. And of course, everything worked fine. And now that I got that in place, I can see the issue. So the fix, I think, is to machine a bit off the end of this bracket here. I'll need to go and look at the cab model and work out how much needs to come off that. And when I was doing the cab model, I was working from sketches that Cliff Hall had sent me, and he had measured his original Threadexpress 2.1, I think. And I've optimized the design slightly to make it more compact, and little errors creep in, and that comes back to haunt you in the end. But as you can see there, that's working. If I can just resolve that issue with clearance there, we'll be fine. So I'll go ahead and I'll finish the assembly and we'll put it in place on the Bridgeport. Yeah, things don't always work out. Alright, I put together as much of the assembly as I have now, including these 3D printed parts for the pivot and the nut and so on. These need to be made in future episodes, but it actually works. So it's not easy to see, but this headstock is moving along its linear rails as we crank the handle there, at least over the limited range I can get until I fix that bracket there. But I thought I'd show you this, so see if you can figure out what that's for. But that'll be a future edition, a little bit of a refinement to allow you to check the accuracy of Threadexpress. But let's go and get this bolted on the Bridgeport and see how it looks. Now, just for the moment, the whole Threadexpress assembly is just resting on a pin, 10mm pin down here at the center point, and it's actually locked in place by two 10mm hex head bolts. So we'll get those nipped up tight. Now, there will be an angular scale on this curved surface here and a 0 pointer on the top of this large plate here, and that allows you to pivot the whole assembly over to get the helix angle of the thread that you want to cut. So you can look that up on the machinery handbook, and you can then ensure that when you're fly cutting your thread, it will actually align with the pitch angle or the helix angle of the thread. So let's assume we've done that, and we can lock that up tight. Alright, that's all rigid, and you can see that's all working now. Headstock is actually moving vertically, and your workpiece will fit in the jaws of the chuck here. Now the next trick is to be able to get the spindle of the Bridgeport in position behind the chuck. So that's going to mean pivoting the ram over and moving the ram back as far as we'll go. The table's going to have to move forward as far as it will go, and hopefully we can get the spindle of the Bridgeport roughly there, and then the fly cutter will cut from the back of the chuck. But I haven't tried that yet. I'm pretty confident we can get that to work. So I'll try that and I'll show you in the next video. And I did mention that things have been going wrong here, that I had a few jobs and a few intrusions into my normal schedule. Probably wondering what that's all about, so I'm going to show you. Yeah, sorry, couldn't wait. I've actually tried it and it does work. So imagine this is the center line of our fly cutter. Here's our chuck. This gives you ample room for a fly cutter, and your workpiece goes in the chuck. So yeah, all good. Right, here's the first of my issues. Now this is my Husqvarna 42-inch ride-on mower, and this is the cutter deck. Now the cutter deck had a rapid kinetic disassembly, basically meaning that the blades chopped into this section of the cutter deck here after I ran over sort of a tree root, and made a complete mess. There's a lot of cut off parts inside there that are all going to have to be rebuilt and replaced. So this is all going to be fabricated, this section around here. Got to patch a couple of holes, but yeah, living on acreage, it means that you've got to mow the lawn fairly regularly. It gets out of control very quickly if you don't. So this has become a bit of a priority, getting this job done. So what's the other thing? Alright, let me tell you. Now this is the major project I've been working on for the last 2 weeks. Now my wife and I have decided to bite the bullet and have a rooftop solar system installed with an inverter and with a battery. And it's a major project. So we're going to have a whole bunch of solar panels on this eastern facing section of the roof, and the rest of the panels will go on the west side of the roof. and it means that you have to get up and check all of the screws on the roof. Any that are corroded have to be replaced, because once the solar panels go down you can't get at them anymore. So I spent the last 3 days unscrewing all of the screws, like the whole lot, where the panels will go. Even though they looked okay, I just didn't want any that were likely to fail once we put those solar panels in place. But there's more. Alright, this concrete footing is where the two 8 kilowatt batteries are going to be bolted down, and the inverter. And in order to sort of shield the batteries and the walls, for that matter, just in case of any sort of excessive heat or worse still fire, you need to have either compressed cement sheet or some sort of fireproofing around the back of the battery system. So these two walls here are just compressed cement sheet bolted down to a timber frame. It's actually under our veranda. And yeah, the concrete footing goes the full width out to the garden there, but the battery system itself will just be in that corner. So yeah, that was a fun job in the sort of the heat of Queensland summer, but we got it done. In the garage here, I had to clear this wall and clean it all. There was all sorts of junk and sheets and bits of mesh and everything sitting behind those braces, so all of that had to come out, because on the wall here will be a box called the gateway. Now the gateway is connected to the inverter via a network cable, and there's an app on your phone that you can use to monitor the performance of the solar panels and the battery and all that sort of stuff, and it can be overridden manually as well. So I had to get that ready. Now here's all the junk that was stored there. So all of this has to be relocated or dumped or whatever. Yeah, it's that stuff that you store forever, and as soon as you throw it away you think, oh, I should have kept that. Now we also had to run a conduit underneath the ground. It comes up where that orange pipe is there, and that's where the network cable will connect back to the inverter. So I had to dig a trench across the concrete there. It goes along the underside of this trellis, and then it goes under the pathway. So across this section of the path here, under this section of trellis, and then it comes up through the corner of the house. So eventually there will be a network cable pulled through that bit of conduit there, and that will go back to the inverter. So again, that was not a very pleasant job in this sort of heat that we've had during summer, but we got that done, and hopefully in about 3 days time we'll have the whole installation done and we'll be generating our own electricity. Now you might be wondering why I have a bee in my bonnet about solar energy all of a sudden. Well, the answer is sort of in 3 parts. Now my wife and I try to be as self-sufficient as possible. We're not entirely off-grid, but we'd like to be that way. And what we do here is we collect and use all our own rainwater. We've got 3 5,000 gallon tanks. At the moment they're all full, so we've got 15,000 gallons of clean water that gets pumped into the house via a pressure pump. We also treat all of our wastewater on site. So everything from the house and the garage goes out to a home sewage treatment plant. It's all treated and pumped back onto the garden as clean water, not drinking water, but clean water. And all of our food waste either goes to the chickens, and they eat most of it. What they don't eat goes into the worm farm or into the compost bin. Now also we try to minimise what leaves the property. So we do have a recycling bin, and all of the cardboard and glass and paper and some plastics go out with that bin once a week. We also have a general waste bin, but to be honest, it only gets filled up by about 1/3, and it goes out once a week. So there's very little that actually leaves this property. Now by the same token, we're trying to reduce what we bring into the property. So we don't use gas in any way in the house. We don't have gas cooking or heating. Everything's electric, and like I said, that's really the only energy source that we're importing, apart from a bit of fuel for mowers and so on. Now, the other thing is that during a blackout, which we tend to get a lot during the storm season, in a house like ours, you've got nothing. So you've got no water, you've got no cooking, you've got no Wi-Fi, everything is run from electricity. And when the power goes down for an hour or 2, you can just sit there and wait for it to come back on again. But if it's more than that, it means you can't have a shower, you can't open the fridge. And that's one of the things that we like about this home solar plant with the battery. It means that you can switch over to the battery and run the house off that during the night time, or if it's an extended blackout. So I do have a 7 kVA petrol generator, but it means going under the house and starting it. It's a bit of a pain to start, and it's noisy and it's smelly, and we don't use that unless we get a lengthy sort of outage. We know it's going to be out for a while, and that means we can go and have a shower and cook a meal and so on. But we'd rather not rely on that. So that's, having the blackout protection is a big deal. Now the other thing is that we tend to be environmentalists. We don't like the idea of actually continually relying on fossil fuels. So at the moment in Australia, all of our coal-fired power plants are reaching the end of their lives, and they will be phased out over the next 5 to 10 years. And you've got two options. You can either ramp up your renewables, which is what's happening now, but we do have an alternative Prime Minister who's hell-bent on the idea of building nuclear power plants. He wants to build 5, and he wants them publicly funded. Now, in my view, it's a non-starter. Our economy is not built for that sort of thing. And I think what he's trying to do is to prop up the oil and gas and coal industry over that 10-year time period that he's projecting it will take to even start the work on the nuclear power plants. And he wants to wind back all of the renewable projects as well. So that's a thing. Politics aside, we just don't think it's a good idea to have to rely on those fossil fuels. So if we can generate our own power here and utilise it with the battery at night, it will mean that we pay a lot less for electricity. Some months we'll have a zero bill. Some months it might be $25, $30, but it's a far cry from what we're paying now. So that's the end of today's lecture. And what I'm going to do now is we're going to go down to the beach. Now, we went down there this morning and we had a swim and the surf was up. Now, I'm not a surfer, but I enjoy watching the people having a surf. And also going to show you some wildlife that we spotted in the backyard, some beautiful pale-headed lorikeets. So sit back and enjoy that. I'll see you next time for more exciting adventures with the Threadexpress version 3. Until then, thanks for watching. I'll see you next time. Cheers. Where would you rather be?